Okay, in our last video, it was a very brief discussion about trigonometric ratios. In this video, we will discuss inverse trigonometric ratios. Okay, by now we have probably seen problems, a situation with a triangle that looks something like this. So we have a right triangle, and we are given that this length of the triangle is, let's just for example, let's say this is 3 units and this length is 7 units. Okay, and it gives us angle x. Okay, so in the past we were able to find a side length using our angle measure and another side length, but now we're needing to find an angle measure using only side length. So what we're going to do is, first things first, is we will set up our equation this way we normally would. So when considering angle x, 3 is the opposite side and 7 is the adjacent side. So we will look at tangent, because that is our trig function that uses opposite and adjacent. So tangent of angle x equals opposite, which is 3, over 7. Okay, so what we will see now is that we need to use our inverse. Okay, so tangent is a function. Okay, it's a ratio, but it's also a function. So we need to use the inverse of this function to undo it so that we can get x by itself. What that looks like is this right here. Tangent and a little -1. It looks like it's to the -1 power, but that just stands for inverse, and then you put the parentheses around the whole thing. Now we have to do it, anything we do to one side, we have to do to the other side. Okay, I had to write it small to fit it in there, but so we're taking the tangent inverse of each side. Now we move on to the next step in our equation. These tangents and tangent inverse cancel. We're just left with x equals the tangent inverse of 3/7, which, once you put this into a calculator, you will get that x is equal to 23.199 degrees. And there's your answer. Now the process is similar for each of our inverse trigonometric ratios. So if we had been given an opposite and a hypotenuse, then we would have done opposite and hypotenuse. We know that sine, we would have done sine inverse. And likewise with cosine inverse if we had been given the adjacent and hypotenuse. That is something to think about as you continue with the process of solving parts of right triangles.